My name is Jude Cadet, and I'm currently here to talk about improving resiliency during change for financial services. I am a systems engineer, and I currently work for Fiserv. Let's get right to it. So this is just a brief overview. Just going to talk about a little bit about me and about Fiserv. I'm going to get into how we're using Redis and how it's been beneficial in our environment, and then I'm just going to sum it up at the end. So first off, just a little bit about me. I currently work for Fiserv as a systems engineer. I've been there for a little over 5 years. I currently work in the Linux and the Unix space. I've worked for other companies. I've got roughly about 20 years of IT overall experience. I've got a degree in networking. But I just like working more often the Linux and Unix space. I've worked for companies like Ericsson, Turner Broadcasting Systems, worked for Sun Microsystems, just to name a few. Currently my current role involves me doing a lot of automation, and I'll do that through scripting as well as coding, pretty much in Bash or Python, or a little bit of Node, and that's just providing tools for what we may need to use on the internal front. Nothing really. I don't really code anything customer facing, but a lot of the systems that I manage and deal with on the infrastructure side do. So a lot of times my concentration always seems to lie around the infrastructure for database systems. So I've worked with Oracle in the past. I've worked with MySQL, MongoDB, and primarily these days I'm mostly having fun working around Redis. I've got a couple of personal fun facts. I've got 2 kids and I've got 2 bearded dragons. So let's get right to it. Let's keep it moving. So who is Fiserv? Just a little bit about the company that I work for. Fiserv is a global leader in financial services. They've been around since 1984. They specialize in payments, payment processing, processing services, risk and compliance, customer and channel management, and financial insights and optimization. Some of our products aren't really directed to, you probably know of, but you probably don't know them under our name. So some of the products like Zelle, we are the ones who put Zelle out and we manage it on the back end. Anytime payment processing or payroll, a lot of that stuff that's handled on the banks, that's us handling all of those services on the back end for the banks and the financial institutions. Currently, we have about 44,000 clients in 80 countries. We've been a Fortune 500 company for the past 8 years. We have been on Fortune's list for great places to work for, I think roughly it's been 6 or 7 years now. And we have about 24,000 employees worldwide. Now, due to the acquisition of First Data, the numbers of employees probably going to change. Our clients is probably going to increase as well. That also puts a lot of the products that First Data used to handle in our backyard as well. So products like Clover and other point-to-point sales devices or products that First Data used to manage is now considered Fiserv at the moment. So if you'd like to know more about Fiserv, you can always go to the website and get more information. If you want to know more about our Fortune 500 standing, you are more than welcome to check on Fortune's website. So let's talk about databases, Redis databases, from a Fiserv perspective. So a couple of things. So first off, Fiserv, we use Redis in several different ways. So we'll use it as a primary database, and a lot of times we'll use it as caching and session state. So as a primary database, there are some smaller instances in which some tools, or internal production applications may use the open source version of Redis. And but primarily for our production loads, we chose to use Redis Enterprise because of the redundancy that it brings, the security that it brings, and of course the support that Redis as a company brings for us. So there are just some things that we just couldn't settle for less for, and which is why we decided to use Redis Enterprise. Now, of course, with that involves with how we're going to set up the infrastructure. So going into the infrastructure side of things, we have a Pivotal Cloud Foundry integration in which we have several large Redis clusters that are allocated just for the Pivotal Cloud Foundry environment, in which there is full automation in that stack, in which customers can go ahead and deploy an application in a PCF, but also pick what you would call possibly like a t-shirt size for what size Redis database and what technologies you would like to implement along with that database. And it would automatically go ahead and create the database on those clusters and deploy the app as well as the Redis database that was needed for it. So we are working in the Kubernetes space. So we have a couple of lab implementations of Rancher in which we are deploying Redis clusters through. So in the OpenShift environment, we also are working with that. So we have a specific cloud team that seems to work on all of the everything that's in the Kubernetes space or our AWS, Azure, and Google Cloud. So we are also looking at OpenShift deployments, and we actually just started working with PKS deployments, and we're working with using outside Redis clusters for those. So all of those things some of those things are kind of in a development stage, but we also have a cloud team, and of course working with our partners in First Data as the merger started to take hold and kind of gel us into one company. We have a joint effort cloud team that is working on deployments for AWS. So the First Data side already actually had production loads working in AWS. We didn't, so they're working on that, and also working on supporting what currently exists out there. We had deployments in Azure, and same thing here. The cloud team is kind of working on managing all of that, and we also are working on tests with Google Cloud Platform, with the Google Cloud Platform. So when it comes to bare metal, we are actually in the testing phase. We have some IBM Power machines in which we're looking to test to see how Redis can work on bare metal in those environments. We don't have anything particularly deployed yet because primarily our environment is primarily virtual. Therefore, our Redis clusters are virtual machines as well, and this is all deployed through VMware. So we've kind of taken hold of that architecture and kind of used it to go ahead and automate deploying Redis clusters as well, as much as we possibly can. So that makes things a whole lot easier and it's just a lot better from a building and infrastructure standpoint. So most of the applications are using Redis for caching and session state. As I mentioned earlier, we have a smaller side for the primary database, but most of our production workloads are using it for caching and session state, and we have really beat it up with a lot of transactions as far as when it comes to login tokens and session state and caching, and it's held up pretty well. So right now, that's pretty much the current state. And of course, the future state of Redis is only going to continue to grow. Some of the pain points that we have come across is initially from the beginning, we were deploying Redis clusters per a project. So if a customer, internally, one of our dev teams, if they wanted to use Redis for an application, we would deploy another cluster for them. So one of the things with that is it ended up becoming a little bit cumbersome because we ended up with several clusters of different sizes, and it's an extra layer of management. So one of the things that Redis has been very supportive and very helpful with is that they are looking into helping us come up with some sort of consolidation scheme. Therefore, we can just deploy databases as needed rather than deploy entire whole clusters for a particular application or project. Some other pain points as far as when it comes to infrastructure is security. Fiserv is very strict on security, and we lock down a lot of ports. So therefore, it takes practically an act of God just to go ahead and get a security port open. So, but we've been able to work through it, and everything with the Redis clusters, even with the ports that are necessary for them to have opened, everything still remains secure. So I know we talked a little bit about the databases that we're using at Fiserv. So let's get a bit more into the modeling of the databases. So right now we have several primary databases which are in a single location. So Redis Enterprise provides so much more features when it comes to redundancy. So when you have a database in a single location, you can have a Redis cluster of 3 or more servers in which you can add what's called replication in order to have an exact copy of that Redis database to be able to fail over to on another node should a node go down. So those are some of the things that are only available on Redis Enterprise. They have what's called persistence, in which it writes a copy of the database to disk. Therefore, if the node with the database goes down, it could either A, fail over, or B, if it's a situation where replication is not enabled and there is nowhere to fail over to, when you bring it back up, it will read the data from disk and refill the cache, and that way you're not taking more downtime just to start from a cold cache. So those are just ways that you can kind of quickly get back up without too much downtime, with minimal downtime, with failovers, and those are just some security things that we found very important that we decided to go ahead and use Redis Enterprise for. Now, this is just in one geographical location. Redis also provides a geo-distributed database in which the databases are in a active state, in which the databases will sync across 2 geographical regions. And I have a few more examples of that I'm going to get into and show you a little bit more as we go on. The ephemeral data store, this is where it's talking about writing the data to disk, so you don't come back up from a cold cache. And it's very useful when it comes to caching and session store and queue management. Therefore, you don't have to go and rebuild the cache off of reading from database from wherever you may have the database. So that way you just bring things back up, the Redis database is back up, and you just read from the cache. The application can continue to read from the cache rather than make extra calls to rebuild the cache. So some key performance measures that we required. So we have some data store sizing, in which we were looking at some of those actually became a challenge, because as we started to implement Redis more and more, we realized that a lot of people in our environment were really satisfied and really liked Redis. So we decided to build more out, and there's some situations where we actually have very, very large Redis databases, and some people wanted to get rid of their secondary database altogether, but they were asking for astronomical sizes for what's Redis case, for Redis's case, and that's just because Redis is meant to run in memory. So for a 50 gig Redis database to allocate 50 gigs of RAM, and also if there is replication enabled, to have someplace to fail over, we're talking about a large number of RAM just to size that out. So that was some of our pain points that we had also had to look into. How feasible for what environment are we looking, to look to build large databases or a large data store for those environments. Some of our performance requirements, a lot of times because we're dealing with financial transactions, there can be a large load of requests, and we have some instances in which Redis has handled that very, very well. So it's definitely been one of our metrics one of the reasons why we had looked at Redis, and dealing with the load and the concurrent connections, and how long will it keep the connection, and how to set TTLs. These are all things that we had to take into consideration when we were first looking into Redis, and Redis seems to have handled it in a pretty, very, very, very good way, which is one of the reasons why we continue to implement Redis across our environment. So right now, there's a heavy, heavy need for automation. So we are talking about the entire life cycle for the application, and Redis support has been very, very helpful. They have a very robust API in which you can do just about anything that you need for the Redis databases via API. So everything from development to the approval to test, and then go through the approvals, go through the initiation process, and then up to prod, up to when the application retires. Just throughout that whole life cycle of the application for the whole CI/CD stack, Redis has definitely been very, very supportive, and the application of using Redis as a database for that has worked out very, very well for us. So. One other thing is, so one of the problems we seem to run into is because, especially when it comes to using Redis as a cache, a lot of people just seem to like to use strings. Strings is universal, so we definitely from a infrastructure side of things. We're always trying to preach the gospel to let other people know that Redis also has other data types that you can use, and not just that. There's other modules. I think there's only, out of all the Redis modules, there's only two that we've used, and I think it's Redis Search and ReJSON, and both of those work very, very well. But there's other extensible modules that can bring, much more usability to Redis, and not just that, but also taking advantage of using other data types, and just getting people to understand that and work out. That's one of our pain points as well. So we're working towards having people or utilize, much more popular features or much more tools that Redis also provides. So now I mentioned a little bit about the active, and this has really proven useful for us in our Redis environment. So active databases are called CRDBs, and the data types that they use is CRDTs. So what is a CRDB? A CRDB is a conflict-free replicated database. It runs in an active state across 2 geographical locations. One of the good reasons why we decided to implement CRDBs is because there is no manual data sync. The data is always syncing, it's always active, and if need be, you can actually have 2 different applications working on both sides, on both geographical sides, and the data will be syncing between the 2 Redis databases, so they'll always be readily available. They have a high availability infrastructure for those. So to actually implement that, there is failover probabilities for them. So, in which you can also use the current existing failovers, such as replication and having a backup copy to disk if necessary. So, and this is all for CRDBs, in which it will happen on both sides on both geographical sides. So you'll have one of the requirements that you have is so of course you're gonna need to have the network WAN with a decent connection between the 2. You will have to stand up 2 Redis clusters, in which you will set, they both are configured to be able to use CRDBs or create a CRDB, and they will talk to each other. So you will also need to have DNS and all the ports that are needed opened. There's a couple of DNS settings setups that you'll have to do. For the Redis clusters themselves, you'll have to set up some name server requests to whoever is managing your DNS, and then of course there's the hardware. Whether it's bare metal or VMs, you're gonna have to set up 2 different Redis clusters in 2 different geographical locations. So one of the things that we had definitely enjoyed, or the idea of CRDBs, was mainly for the fact for failover. So we wanted some sort of disaster recovery location without having to worry about any kind of manual syncing. I know with Oracle and Golden Gate, it can be a little cumbersome. So you will have to worry about actually forcing the sync, in which when it comes to Redis's CRDB architecture, the data is always syncing, and you don't have to force a sync. Should one site go down, the other site will keep on moving. When the other site comes back up, the data will automatically initiate a sync. You don't have to force a sync. So in the case of a DR setup, this was perfect for us. So, as I mentioned, some of the challenges was just getting through, all of the security setups, such as setting up ports, making sure the right ports were open between both data centers where we had the cluster sitting. The hardware, of course, well, right now everything is virtual. But if we were dealing with physical hardware, then we would have to worry about actually purchasing the hardware. But nonetheless, it still has to be set up on both sides, and you have to have all the ports open. You have to have DNS enabled, and Redis provides all of the proper DNS settings that you will need to implement a CRDB. CRDBs also have their own data types, in which that are associated with it, and data types will sync in different ways. One of the challenges that I mentioned before was that we always seem to have problems with having people to move out of the mindset of just using strings, because strings sync in a different way. All of this information is definitely available on Redis's site if you want to know more, and you can know how to take advantage of different data types, such as strings, ints, or whatever may need be for your environment. Monitoring. What are the challenges with monitoring? Well, Redis, like I said, Redis has a very robust API. So you can actually, there actually is a Splunk plugin for Redis as well. Splunk provides that. So if you're using Splunk in your environment, you can easily pull up metrics and data and error messages on your Redis cluster as well as your database and see everything that's going on in Splunk. That's one of the best ways to take a look at things, and that's what we've started implementing and started working with. So here's just an overall view. So when it comes to CRDBs, just to kind of give you an idea of how we've set things up at Fiserv. So remember I mentioned we're primarily using it for disaster recovery or failover sorts. So as you can see, we have the application instance A running in our data center in Georgia, which is using Redis. It's connected to a Redis instance in Georgia, and the data will sync back and forth between the two Redis clusters with our database, with our environment over in Texas. And application B is connected to it. Now, should application A go down, or let's say the entire data center in Georgia goes down, we can just switch everything over to the application instance in B, in which all of the data will be fully available. And should the data center in Georgia come back up, Redis will automatically initiate a sync, and we won't have to worry about actually forcing a sync. So current state is disaster recovery. Future state, we were looking at actually having a active environment in which we're using both the applications at the same time. And we may just have one application instance serve one region and the other application instance serve another region of the country, or maybe between two different countries or whatnot. Some other future state models that we were looking at is doing a three-way sync with CRDBs, in which we may have a CRDB instance in our data center over in Arizona, in which all three of those data centers will have a database that simultaneously syncs between all three of them. That was talking, we don't have any particular implementations that has asked for it, but if need be, we have mentioned that we do have the capability. Now, this is just to show you a little bit about how the data flows with a CRDB, just so you can kind of get an idea. So if you take a look, there's application instance A, in which it will talk to the CRDB via the endpoint that is given for that database over there in cluster 1. And then cluster 1 will talk to cluster 2 via a process called the syncer. And the syncer automatically, every time there is a write to cluster 1, it will go ahead and talk to the syncer, and the syncer will go ahead and perform that very same action in cluster 2. And then in cluster 2, that syncer will talk to the same database endpoint in cluster 2 and perform that write. And then, of course, you'll be able to read it from the application instance in B. And it will turn around and go ahead and do that vice versa in the other way. So that's just to give you an idea of how data flows in an active state. So as soon as any write is initiated on any side, cluster 1 or cluster 2, it's immediately reported to the syncer process, and the syncer process will say, hey, speak to the endpoint and say, hey, a write has occurred or a change has occurred. Go ahead and change this in the other CR, in the other database, in the other region. All right, so that's pretty much everything that I've got. So we talked about, a little bit about Fiserv and how we're implementing CRDBs and how everything has seemed to have worked out for us. We plan on continuing to use and grow with Redis in our enterprise. It's been very useful. Redis Enterprise itself is pretty much the way to go if you're looking for security, redundancy, failover, as well as just a strong support. They've been extremely helpful, and they've been able to address our needs as we needed. So. All right. If you have any questions, you can reach me at Twitter. My handle is @cadet_J3. If you have any more questions for Redis Labs themselves, you can always go to their website. But I will be more than happy if you reach out to me on Twitter or follow me on Twitter, and I will answer to the best of my ability and at least give you an idea of how things has worked or not worked for us on the Fiserv end. All right. Thanks, everybody, and hope you've enjoyed this talk.